Hello everyone, welcome back again. My name is Jesse, and in this wonderful tutorial, we're trying to see how to interpret our ML or our machine learning models. So why should I trust your model? So most ML models are able to make accurate and very high predictions, right? But it's not enough for you to be able to make those predictions. You should be able to explain what your model is doing. The reason is that every software has bugs. Even so, ML models can also have bugs. So one of the reasons why we have to interpret your model is to enable us to detect the bugs inside those models. So why do we need to interpret that model? So first of all, to help us to detect bugs, again, some ML models are having a very high risk. For example, self-driving cars, right? Or maybe you're working in the health industry. Any machine learning model that affects humans' decision in a higher level, right? In a very high risk of environment needs to be interpreted. For example, in health, you need to interpret it. In case of machine learning, in case of self-driving cars, you need to interpret it. In case of finances, you need to be able to interpret it. You need to know why the machine learning model is making that particular prediction. So some ML models don't need explanation. For example, if you're working in low risk environment like recommendation engine, you don't need any ML explanation, right? You don't need interpretation. And then in case you are working with a model that has already been, or a field that has been extensively studied, like OCR, like optical character recognition, handwriting analysis, you don't need to explain it, you don't need to interpret it. But if it affects human decision, if it's a matter of life and death, then you need to do it. So the reason is that if you do that, it helps us to detect bias, right? Because the data can be biased, and the ML model can also be biased. It helps us to identify misclassification. It helps us to be able to know how reliable our model is, especially in self-driving cars, so that we be able to trust our model. And then it's easier for humans to trust a system that displays a decision compared to a black box model that just make predictions. So when do we need to interpret model? So the only time you need to interpret your model is that if your model is going to have a significant impact on something, you need to interpret it. If your model is going to be a matter of life and death, like in health, finance, self-driving cars, you need to be able to interpret it. Now let's see some useful packages to help us interpret our model. So we have LIME, we have LI5 or Experience like I'm5, we have Sharp, and there's several other models. Now to install, let's just go with pip install LIME, pip install Eli5, pip install Sharp, right? So LIME Python model. So let's see first of all how to work with LIME. So LIME stands for local interpretable model agnostic explanation. So it is local, it is not a global, right? It's explaining it locally. Then it is model agnostic. That means that it's not going to explain your model based on assumptions. It is going to be agnostic to your model. It's not going to use what it thinks it is. It's going to explain it as it's supposed to be. So it's an algorithm that can explain the predictions of any classifier. It is very, very good with classifiers or regressor in a faithful way. How does it do that? It approximates it locally with an interpretable model. You just pick a simple sample and explain it locally. Now let's see how to work with it. So I'm just going to load our EDA package of importing pandas and then NumPy. Then I'm going to import our visualization package. So let's load our dataset. We're using the famous iris dataset. So it's going to be df, going to pd.read underscore csv. Then this is going to be our iris dataset. Right, so that's what we are trying to work on. Perfect. So let's check what our dataset have. So df.head. So this is the iris dataset. We have sepals and then we have the species, right? So we want to try to classify based on species, a particular kind of species is based on the features, right? So these are going to be our features, these are going to be our classes. So let's check for the shape of this dataset. So we have our df.shape, then we have about 150, right? So let's check for our column to check for columns consistency. So df.columns. Perfect. So now we have our columns. So let's first of all build our features. So our features is going to be these three ones, right? These are like our features. So I'm just going to use our column here to build our features. So let's call it as X for our features. So I'm going to put it inside this. So that is going to be our features, right? Perfect. Now to get our labels, label is going to be Y. We are going to be using our df, then our species. Right, so this is going to be our labels. Perfect. Now, one of the things is that when you are working with, to be able to explain your model, you need a class name. So let's create a class name. So the class name is going to be y.unique. So if I go with y.unique, it's going to give me all the unique values, right? So these are the unique ones. So this is what I'm going to use as my class name. So let's put as class Let's go on names. Perfect. That's nice. Now let's load our machine learning model and build our model. So I'm going to be using logistic regression. Although it's a classifier, right? It's called regression. Then you can also use random forest from a sample. Then let's create our metrics, load our metrics to measure our accuracy, and then our test train to split our model, right? So this is going to be our S train, Y train, then S test and Y test to split. We are splitting on 30, 70 on a seed, random seed of 7. So it gave us an error. So the reason it's giving us an error is at 460, 450. So let's check here. Right, so here. So to be DF rather. So you have to check it from here. So that's what the mistake I made here. So let's go back and then split it. Perfect. Now it's working well. So if I check for my S train, right, dot values, it's going to give me all the values that are there. Very interesting, right? Then I can also check for the shape of this my S train that I have, because I splitted it on 30, so it can give me this particular value. Very interesting. Now let's build our model. So I'm just going to create our model.logistic regression of this particular option. Then I'm going to fit our data set together with our training data set. Perfect. So it has built it in a very nice way. Now let's make our prediction. So to make our prediction, it's going to be very simple. I'm going to go with model logic regression dot predict. So we can predict it on our S test, right? So let's put it on our S test. Then see that it's going to give us Virginica, Setosa, Setosa. Very interesting. It's predicting it very well. So to check for the accuracy, you can just go with our accuracy. We have our accuracy score. Then I'm going to supply the particular star that I have. So it's going to be, let's check for our predictions. It's going to be Y test that I have right over my model dot predict. Then I'm putting it on my S test, right, so that you'll be able to test it very well. So it gives us an accuracy score of 0.88. That is 80% accurate. Now let's see our prediction. Let's interpret our particular model, right? So how do we interpret our model? So let's work on it and see. So we're trying to see how to interpret this particular model. Why it give us this particular accuracy of this, and why it's giving us this particular prediction. So let's see how it's going to be. Perfect. Right. So to even us this particular stuff. So now let's make a simple prediction to see how perfect our model is. So we're going to go to model dot predict. Then I'm using it to predict on something very simple, right? So let's make a simple prediction. So let's go to npage dot array bracket s. Let's make a simple prediction, right? S test dot ilog. Then let's make it, let's say I'm predicting value 8, something very simple. Dot reshape. So we are reshaping it as 1, right? So this thing that we have here, this is just going to give us our value. So let me copy this one so that you don't get confused. So we can just make it like this. So let's say example species, right? Then I can make it like this. So if I go with this and I check my example species, that is the values, right? So we want to be able to make a prediction on this. So to make a prediction, I can just go with my example species. Let's see whether it's going to give us as a particular kind of stuff. So this is Setosa. Very interesting, right? So this is Setosa. If you check from here, we know that this is 8. So 0, 1, 2, 3, 4, 5, 6, 7, 8, right? So this is 8. So here was Setosa. Then I put it as 8 here. And I put as 8 here, it gave us as our speeds of Setusa. Very, very interesting. So that is, it's making a very accurate prediction. Now, how or why did it make that prediction? Let's see why it made this particular prediction. So to do that, you're just going to create an explainer. So it can be tabular, image, or text. Or then you're going to create your data. You're going to have your data, your class name, your model, and then your function. So let's load our LIME package to import LIME, then import LIME tabular. Perfect. So let's set our feature name. So our feature name is going to be our feature names, right? So let's call that our feature names. Then how is the feature name going to be? Realize that our feature names is just coming from our columns. So we have our columns here. So df.columns. So these are our feature names, right? So these ones here are our feature names. So let's copy this one as an array. Then let's put it here. So this is going to be our feature names. Perfect. Right, so this is going to be an array of our feature names. Now again, we need to be able to get our data. So we have our feature name. Let's create our class. So this is going to be our class names. Our class names was y.unique. Remember that it was y.unique. Perfect, right? Remember that this was our class name. Then if you go with our class names here, remember that it was this, right? So these are our class names and these are our feature names. Perfect. Now we need to get our data. So to get our data, it's going to be our s.test, or it can be anything, s.train, right? Dot values. So to generate an array for us, right? s.train. So we need to be able to work on that. So it's going to be our s_train dot values. So this is going to create an array for us. So this is the array that we're going to use as our data set, right? So we have the requirement is that you need your explainer, we need our data, we have our class name, we have a model, and we have a function that will provide the predictions. So let's check and see. So we have all of them. Now let's create our explainer. So to create our explainer, it's going to be our explainer, then lime.tabular, right? The lime tabular explainer. So the tabular explainer is for tables. Then if you are using text, you go with lime text explainer. If you are using image, lime image explainer. So this is going to be our data. Then our feature names going to be set in our class names. Right? We're going to set this discretized continuous is equal to true. That is the basic idea about it. So we have created our explainer. Now let's initialize or instantiate our explainer, right? So to instantiate our explainer, it's going to be very simple. So let's call it as ESP, then our explain dot explain. Right, so we have explain instance. Then this explain instance is going to take our particular value. So we have test, what we are working on. So let's put it on any stuff like that. So this is, we want to make a prediction on one particular value, right? On one individual particular value. So dot ilog. So we already had this as 8. Remember if we had this one as 8, then give us as what Setusa, right? So what we can use that same stuff here. 8, perfect. That's what we are trying to predict on. Then we're going to apply our model. So model logistic regression dot predict proba. Right, perfect. So that's the function we are using. Then the next thing that we need to is apply our number of features that we want to predict by. So we have 4 features. We already have 4 features here. 1, 2, 3, 4. Right, we have 4 features. We are using 4 features, or the 4 of them. Then the next thing we need is that we need to be able to set the top level. So you can automate this one. Top levels is equal to 1. Right, perfect. So going to work with the magic behind. Perfect. Now that I've been able to work on it, so if I check for this ESP here, so this is going to be the explanation, right? Perfect. Now let's show it here. So to show it, it's going to be this format. So ESP.show in notebook, then show the table, then show all false, right? So this is going to print it perfectly in a very nice format for us. Very nice. So this give us a setosa. Realize that we already have this one as how do we call it? We had the interpretation here, species, which is 8, was setosa, right? That's what we have. So that explain. So it's trying to explain why it gave us setosa. So this is the reason. So this is the prediction probability. This is the particular rating, and these are the features, right? So the color is very, very important. The color is very, very important. So the reason is that this color, the color yellow, this color here is for setosa. So you are going to check out the probability. So the prediction probability for this setosa is 0.899. Then for vesicular is 0.12. So the reason it's giving that the color blue is matching blue here. So blue that is taking a petal length. The petal length is greater than 1.5. So it is contributing 0.18 weight of its weight to give us this setosa. Again, the sepal weight is also contributing 0.12 to give us this particular setosa, right? That's why it's given us the same color. So setosa, color blue. And here is the blue. The one that is given us an odd one is the petal, which is given as 0.20. So that is the one, right, that is found here, right? That is why it gives us as setosa. So the color, the actual color is the setosa. So anything you see here is the actual one. So it is not setosa, but it's rather setosa, right? So this is not setosa, is only the petal length, which is the odd one out. And these colors show that it is setosa. So that's the narrative. You can just check how it is. Now let's verify our sample. So we realize that we had our sample as S, and let's go test.ilog. We realize that this was the one that gave us that particular value. So these are our value, and then give us a very interesting stuff that we use to work on. Now let's try it on something different again. Instead of resampling, let's try it on another value. This is another example. So let's go to another sample. So this is going to be a sample of 10. Right, so if I'm going to make a prediction on this particular stuff that we had, it's also going to give us total different value. So to make a prediction of this sample, so let's call it as model, right, dot predict. So let's make not log predict of our particular sample. So my sample. So I work on this vesicular. Very, very interesting. So in case I want to explain this particular stuff, I can also do the same thing. So let's try it and see how I'm going to explain it. So I'm just going to copy this here, right? And then go to use it to explain it. So this here and this is going to be 10. Right? As we have a 10. Then the next thing is going to be our particular value that we have, which was this. So show here. So I'm going to use it to explain our particular value. So let's make this one as 2. 2 and this as 2, right? Perfect. So if I check it, it's going to work interestingly. Oops, give us an error. So let's check it and see. Perfect. So this is given us as vesicular. So why is it given us as vesicular? The reason that if you see the color here is orange, right? So that means that there is contributing 0.21 of the petal length to give us vesicular, sepal length of 0.818 to give us the sep of a vesicular. So the features that it is using to give us this prediction is the petal length that is greater than 4.10, and then the sepal length that is less than 6.30, right? That is giving us this particular value. That's why the same color here. So vesicular. These are the particular features. That is the basic idea. Now let's see how to work with Eli5. So Eli5 means that it's pretty like M5, and the concept of Eli5 is that it's going to use the weights, right, and then the biases to be able to explain it. That is the basic idea about it. So it's very useful when you're working with test processing utilities. Very, very interesting. Okay, now let's see how to do that. So the basic idea is I'm just going to provide your model, provide your features, and then the class name. So let's import Eli5. Then you're going to show the model that is going to be used to do all the explanation, be able to do all the prediction. You're just going to go with my Eli5. Eli5 explain diagram 5. Then show weight. So if I go with show weight, you have show prediction. Show prediction is for showing an individual prediction, right? Sample. Then show weight is for the entire data, right? So show it for the model, then I'll supply my model. So if I go with supply my model, it can just go straight away and then give me the results, right? So these are all the results that is given. You cannot see it very well, but I think so. It's going to just give us the weight and the feature without giving us the particular value and then the weight. So we have setosa, top features, we have vesicular, and these are the weights it's going to use to determine which one is vesicular, which one is vaginica, which one is setosa, right? Very interesting. So I can also do the same thing here with the tops, right? So you can also set tops here to give a particular value. So let's call that tops. By default is 10. So top 10, right? It's almost going to give us the same stuff here, right? Very interesting. Okay, perfect. Now let's see how to clearly define it, because these ones are not giving us anything. This is just giving us values. I want to know which of them is being contributed. Is it peta or is it sepa, right? So let's see how to do that. So it's going to be like this. To clearly define it, it's going to be Eli, right? It's going to be our Eli5 that we have. Then I'm going to supply the individual stuff there, right? So it's going to be our feature name, because feature. So feature name is equal to feature names. Perfect. Then I'm going to supply my target name. So it can be target name. So for that target name is equal to my class names. Perfect. So with this, if I explain it, it's now going to give me a particular value. So you see that here, separate length, separate weight, better weight, like explaining it well with these colors. I don't know whether you can see it. Right, so that is how to work on it in a very nice way. Very, very interesting. So that is more specific. So it also shows bias. So the bias is just an intercept. So bias is intercept where our lines intercept the biases, right? So it can, in ML we call it bias. Very interesting. Now, so let's see how to make explanation for a single prediction. So to make a single prediction, let's go with show predictions, right? So it's going to make it for a single prediction like the one we have here, which was 10. So it's going to tell us why it is that. So when you are checking it, you are checking it here. These ones, you also check it these ones. Okay, oh, this is better. Okay, this is better. So now here you could have seen it. Oh, sorry for that. Anyway, okay, so with here you can, if you want to check it very well, you are using these ones to check. You are using the score here, right? So the higher the score here, that means that's where it is. So this vesicular is giving us a probability of 0.50. That's the highest for all of them. Then this is the score, and then the top features that is contributing. Right? So these are the top features that is contributing to give us that particular stuff. Very interesting. This is giving us some biases. Okay. So thank you for watching. So the last thing that in case you want to explain the weight, you can also use the same thing. So Eli5 dot explain weight. If you have explain weight, explain prediction, is it the same thing as show weight? Then it's going to do the same thing as we have here. So model regression, and it's also going to give us the same thing that we have initially. So that is the basic idea about it. So Eli5 usually works by explaining the weights in a simple way, while the LIMA or LIME, I said LIMA, LIME also works in a very simple way by using local interpretable model agnostic approach, also surrogate approach. Thank you for watching this long tutorial. In case you have any question or contribution, you can just put it in the comment section so everybody can benefit. And please don't forget to subscribe, share, stay blessed.